Hello everyone, thank you for watching my coding channel, and today I want to talk about 4 things I think every software developer should know. So the first thing is I think that every software developer should be able to program and think in different programming paradigms. So what I mean by a paradigm is a way of thinking. And in programming, we have several such paradigms. For example, we have imperative paradigm, and languages like C++ and Java are in that paradigm. When you program in C++ or Java, you usually think in terms of step-by-step instructions. For example, you might declare a variable, and then you tell the computer, do like loop from 0 to this variable. So you think in step-by-step instructions that you give to the computer, and well, that is the imperative paradigm. And so there are other paradigms. For example, in contrast to imperative paradigm, where we talk about step-by-step instructions, we have functional paradigm, where instead of step-by-step instructions, we think in terms of functions. So for example, in order to solve a problem, we might tell the computer, do this function, and then take the output of this first function and put it in this second function, and and then combine those two outputs into the third function. So instead of thinking about like individual variables and step-by-step instructions, you think in terms of how different functions cooperate with each other, and you're thinking about building a pipeline of functions and design a way for the data to flow between those functions. The reason why I think it's important to know different paradigms is because it makes you a well-rounded software developer. You know how to approach different problems from different perspectives. So for example, you might have a problem which is very suited for imperative thinking, but maybe the next day you get a problem which is more easily solved with functional thinking. So that's why I think it's very important for all software developers to at least be able to think in terms of functional and imperative programming paradigms. And I have to mention there are other paradigms as well. For example, you have logical programming languages like Prolog, and that's a whole other paradigm which you might be interested in. And although you mostly will use imperative programming and object-oriented programming, those other paradigms will make you a more well-rounded developer. The second thing is that I think that every software developer should be familiar and be able to think in terms of time complexity and big O notation. And what that means is that if you look at an algorithm, you should be able to recognize how this algorithm will scale with the input data. So for example, if I have an algorithm that takes 4 seconds to execute with 5 numbers, how many seconds will it take to execute this same algorithm, but when I give it 10 numbers as input? Will it take 8 seconds, double as much as with 5 numbers, or will it take 100 seconds if I double the input? And this depends on how you implement the algorithm. And some problems are very hard to solve with a simple algorithm that scales linearly compared to the input data. But in other cases, you could actually improve your time complexity and make your algorithm scale better for bigger input sizes. And that's a very important and fundamental thing, I think. Because when you're building, for example, an iOS app, or you're building a website, or maybe you're building some kind of server, in each of those cases, you'll most likely use a loop. And if you're not careful, you might use a loop, and then inside that loop you might have an inner loop, which might be unnecessary. And if you're thinking in terms of time complexity, you'll try to avoid the inner loop at all costs. But another software developer that isn't familiar with time complexity might not even think about the issue of having an outer loop and then an inner loop. So that's the reason why I think time complexity and big O notation are very important. And I think that every software developer should be familiar with those concepts. The third thing I think every software developer should know about is basic software security. So, for example, when you're building a system where you have a front end, a client, and a backend, a server, and they communicate with each other through the internet, you should think about what kind of security problems could arise. And there are some basic problems which are very easy to make if you aren't familiar with those. So the most well-known security issue is SQL injections. And so if you're familiar with databases and SQL, you know that you write queries. And so back in the days, before this was established as a very well-known issue, so people had input forms on their websites where the users would input something, and then the developer would just take the raw input data from the input field and paste it inside of the SQL query. And so that makes a problem, because the user could type SQL data inside of the input form and that way inject his or her own malicious query into your query. That's an example of a simple problem that might arise if you aren't aware and if you aren't familiar with the basic software security issues. And most of the applications built today are usually some kind of online service. You might build an app or a website or anything. For anything to be useful today, it should be able to. It should be online. Like most of the services we use today are online services. And so, as a software developer, you will most likely work in some kind of project that has to do with the internet and communication through the internet. And that's why I think that every software developer should know the basic security issues that could arise. And so finally, the fourth thing I think every software developer should know about is how to write clean code. Clean code means different things in different code bases, but what I mostly talk about is writing your code in such a way that other people should be able to read it, understand it, and extend it. They should understand your way of thinking and be able to continue developing your code base. And I think that really this comes with practice. You should practice reading other people's code, and you should practice writing your own code. And as you probably recognize, if you've written some code and then left it for a couple of months, and then you come back and you see these different design flows in your thinking and your construction of different methods and classes, and you immediately know how to improve it that you didn't know just a couple of months ago. You didn't think about your code in that way. So I think it really comes to practice. And also different code bases have different sort of rules. So if you're joining a new team, I think you should look at the code base and identify the different patterns and the different conventions that people use in that particular code base. It could be simple things like whether you have the curly bracket on the same line as the function name, or if you have the curly bracket underneath the function name, the line with the function name. It's a very small thing, but I think in the long run it makes a difference. If all the developers try to write code that is in line and consistent with the rest of the code base, it will make a difference in the long run. The code base will be cleaner and easier to read, easier to pick up, and easier to extend and develop new things. So that is why I think clean code is very important for all developers. And that concludes this today's video. Thank you very much for watching, and I see you next time.